Hello students, welcome to Dr. B.R. Ambedkar Open University. As a part of the MBA program first year second semester operations management, today we are going to discuss about the unit 5, that is product and process selection. The objectives of this particular lesson are that after this class you should be able to understand product selection, process and the new product development process. You should also understand the concepts of CAD, that is computer aided design, CAM, computer aided manufacturing, CIM, computer integrated manufacturing, FMS, flexible manufacturing systems, robotics, lean and agile manufacturing. You should also know the meaning and importance of process selection. You should be able to discuss the concepts of product life cycle, process life cycle and the product and the process mix. Let us start with how companies select a product. The product selection process is a systematic way in which a company chooses a new product or a service it could develop and then launch in the market. It starts with identifying the customer needs, the gaps that are existing in the markets, as well as the business opportunities. Now, once ideas are generated, all these ideas may not be accepted because the ideas would be discussed and some of these ideas would be dropped during the screening process. We could also be looking at the criteria like the demand potential, the cost involved in terms of developing the product, the feasibility of the product, as well as whether this particular new product aligns with the company's strategy. The best option is then developed into a prototype. Prototype is basically a working model. The best option, as I told you, is going to be developed as a prototype or it is developed as a pilot to test its practicality and market acceptance. Finally, the selected product is approved for full scale production and the launch in the market. Now, what could be the steps in terms of new product development? As you have seen, NPD is generally the term that is used to abbreviate the new product development. New product development basically has got 6 stages. Now, the first stage includes the generation of ideas. As many ideas as possible are generated during the first step, and once these ideas are generated, these ideas are screened in terms of looking at whether these ideas align with the company's strategy, whether these ideas cost more for the company or less for the company. These ideas are also evaluated in terms of looking at what might be the demand expected for these products in the market. And then of course, the technical evaluation in terms of the technologies that are required to produce this product as well as the technologies that are used in the functioning of this particular product are also evaluated. Then we are going to look at the commercial evaluation, which is related to basically estimating the demand for this product and what could be the price at which this product would be sold in the market. Once after these steps are done, the final product development is done where you are going to produce a prototype, which is a working model, and once this prototype is tested and finally it passes through all the tests, we are going to go with the test marketing where the product is initially tested in some of the markets to find the acceptability of the product in the market, and once this particular part is successfully completed, we go with the launch of the product on the full scale, and then we are going to go with the commercialization. Now, what you see on the screen is what is termed as product idea mortality. What you can understand from there is when we start with the ideas, that means a product idea mortality curve that basically reflects the sharp decline in the number of viable products or ideas over a period of time, where most of the new ideas fail and are mortally rejected during the development due to technical or commercial infeasibility. What it basically means is when you start with a set of ideas, you have too many ideas, but as you keep on screening them and then basically you are testing them in terms of their compatibility with respect to the technology, what is the available technology, and then you also look in terms of the commercial feasibility, the cost that is involved in terms of producing this particular product, the kind of demand that is available in the market. All these ideas will not survive all these phases. So, if you start with maybe probably 100 ideas, finally 4 or 5 ideas or maybe 2 or 3 ideas might be finally taken up by the organization. Not all the ideas that are generated are going to pass through all the stages through which we scrutinize the viability of the ideas. When we are going with the product design, what might be the factors that could be considered? The first one is what is known as standardization. So, when we are talking about standardization, let us start with an example. Now, if I look at a car tire, now the car tire is standardized in terms of its dimensions, in terms of its width, in terms of its diameter. So, what happens here is when a tire is produced, it is produced to the same size for a particular kind of a model, so that we can freely interchange these tires. Or another simple example is a light bulb. You can in fact buy any company's light bulb and the bulb is going to get fixed in the holder, because the dimensions to which these are produced are the same. This is what is known as standardization. That means only specific sizes of products are made as well as sold. The second principle is related to what is termed as modular design. Now, modular design is all about how you decrease or reduce the complications in the what you call assembly of the product. That means, can I easily build products which are easily detachable as well as which are easily assemblable. That means, you can assemble them very easy. This is what is known as the modular design. Then comes what is known as the form design. Form design is in terms of basically how the product appears to the, or how the product appeals to the end users. Functional design is basically related to how effectively the product works, because the product is designed for a particular purpose, how effectively the product is going to work as intended. That is where you need to find out the difference, or you need to appreciate the difference between form design and functional design. At the same time, we are also going to factor in the design cost, what is the cost involved in terms of the designing the product as well as the production costs. Now, once you produce a product, even before producing, you should also look in terms of the repairability of the product. If tomorrow there is a problem associated with this particular product, can it be easily repaired, right? Without considering this, you cannot produce a product, because the moment product goes out of order, you should not discard the product. You should give a chance for the customers to get it repaired. And also, we are looking at the redesign, where over a period of time you are going to improve the design of the product. And at the same time, today when you are talking about the products, as the days pass, we are looking at products that are produced in smaller sizes. Producing the products with the same kind of functionality at smaller sizes is what is known as miniaturization. That means, you are producing a product at a very small dimension, but at the same time the product is actually capable of doing all the functions for which it is actually designed. Let us look at the term called as automation. Now, what is automation? Basically, when we are talking about the term called as automation in the context of production, we basically look at the interface of the computing systems in the production process. Now, these are basically divided into 4 or 5 types: CAD, CAM, CIM, FMS and robotics. So, computer aided design, as the name itself makes it very clear that we take the support of the computers during the design of the product. So, what happens here? You are going to test various designs on the computer. You are going to basically have the best design by simulating it on the computer. That is the advantage when you are using the computer design. The second one is computer aided manufacturing. Can we make use of computers in the process of design, machine tool control as well as the flow control? We are looking at even deploying computers in order to control the machine tools also. Now, computer integrated manufacturing, where the role of computers is more into the manufacturing, it is basically the use of computer systems to integrate and automate all aspects of the production. That means, when we are saying all aspects of the production, it includes right from the design, the planning, the manufacturing of the business processes, and also we are looking at a higher efficiency as well as higher flexibility. Continuing the discussion, we have seen what is CAD, what is CAM and what is CIM. Now, when it comes to FMS, which is known as flexible manufacturing systems, This is a production setup that uses computer controlled machines and automated systems to quickly adapt to different products or changes in demand with minimal downtime. What do you mean by minimal downtime? Say for example, if a particular manufacturing facility is moving from one set of product to another set of product, you need to make a lot of changes in the production system as well as in the layouts. But when you are using the flexible manufacturing systems, you do not require to make so many changes. That means, with minimal downtime, you are able to adapt to different variety of the products. That is what is known as flexible manufacturing system or FMS. And finally, when we are talking about robotics, it is the branch of technology that designs, builds and uses programmable machines. Now, you know very clearly that programmable machines are also known as robots. These robots perform tasks that are often repetitive, complex or hazardous for humans. There could be some of the tasks that are hazardous for the humans. In those cases, you can use the robots instead of human beings. At the same time, there could be some repetitive tasks which can be done more efficiently by the robots. Even in this case, you are going to use robots. Let us have a look at what is lean and agile manufacturing. Now, lean manufacturing is a production process that focuses on maximizing value for customers by eliminating waste, improving efficiency and continuously optimizing the processes. That means, basically when we use the term called as lean, please understand that we are trying to maximize the value, at the same time we are trying to eliminate the waste, we are trying to improve the efficiency and we are also trying to continuously optimize the system. We are trying to get the best out of the existing system. Now, agile manufacturing, as you know, agile is your ability to move very fast as well as easily. So, when we are talking about agile manufacturing system, it is a production approach that emphasizes flexibility, speed and responsiveness to quickly adapt to the changing customer needs as well as the market conditions. That is the reason why we are using the term called as agile, your ability to adapt quickly as well as effortlessly, how you are going to make changes to the system so that you are going to meet the changing needs of the customers as well as the market conditions. Any production system will depend on a process. Now, how do you select a process in order to produce the products? So, process selection basically is related to selecting the kind of production process to have in the plant. For example, we have different types of processes. It could be batch production, it could be assembly line production or it could be any other kind of production. So, process selection has a technical dimension. Processes should be able to meet the required specifications. Process selection has got also a business dimension, not only a technical dimension, we are also looking at the business dimension. That means, it should enable you to get into the market and stay there once this is done in order to win the orders. So, this is about the process selection. Now, what are the factors that affect the process selection? Adaptive processes, that means, process selection has to adapt itself to a number of changing factors like the capacity, the lead time, the flexibility and also the trade-offs between material, labor and capital, also the trade-off between the volume and variety. As we discuss, you will basically understand what we mean in terms of a trade-off. We are also looking at the effect of environment, that is the environmental effect. Process selection should respond to the environmental changes, especially with respect to the changes in the technology. Whenever there is a change in the technology, the process should be able to adapt to the changes in this technology. And the next scenario is related to the volume versus variety. Now, when we use the term called as variety, we are producing different sets of products, not the same type of product. When we are talking about volume, volume is high volume basically relates to the number of units that you are producing. The more the number of units that you are producing, the higher the volume at which you are basically operating. So, when we are talking about the volume versus the variety, it requires skilled technicians, general purpose machines. You also require production planning and control. You also require the capability to mass produce specific machines, right. And also when you are talking about the production systems, you have two types. One is you produce something only when you get an order, that is what is known as produce to order. You get an order, then you are going to produce. The other part is you produce to stock. That means whether orders are there or not, you are going to produce large volumes, stock them and then you are going to sell them. Now, what are the types of transformation process? What do you mean by transformation here? Transformation basically refers to the conversion of the input to the output. There are various types of transformation processes. The major ones are divided into 5 categories: project technology, job shop technology, batch technology, assembly line technology, and continuous flow technology. In the coming slides, we are going to discuss about each of these technologies in detail so that we will understand the intricacies that are related to the production processes. It is a process technology suitable for producing one of a kind of the product that are tailored to unique requirements of each of the customers. What it actually means? Say for example, there is a construction of a metro train system in a particular city. Now, the kind of the route, the kind of technology that is involved, the kind of challenges that are involved in basically executing this project are unique. The same kind of project, even if it is taken in another city, the specifications as well as the challenges that are involved as well as the designs that are involved are going to change. So, project is a one of a kind of endeavor that is taken up by firms. So, a project consists of unique time consuming activities performed in a sequence. So, when you are talking about a project, you are basically looking at a sequence of activities that are performed, where it is very clearly defined in terms of which is the preceding activity and which is the succeeding activity. Each project has some definite completion time and cost associated with all the activities of the product till its completion. This is also known as project cost. Now, let us look at the characteristics of project technology. We have already mentioned that a project is a one-time endeavor. Projects generally have a relatively shorter life cycle with a definite beginning as well as a definite end. So, project starts, project ends, and there is a time period in between. Now, resource requirements are not uniform. Resource allocation is one of the major challenges as a part of the project planning. Now, temporary manpower, they always look for alternative jobs when the project is getting completed, because after the project is getting completed, no longer the project will be existing. Therefore, they look for other jobs. Each project consists of a host of activities having interdependencies. That means, unless you lay a foundation, right, you can't build the walls. So, foundation has to happen before you build the walls. After you build the pillars, then you can go with the slab, that is the roof. So, interestingly, all these are interdependent. A project typically has activities that are interdependent in nature. Each project consists of a host of activities having interdependencies. We generally use techniques like PERT and CPM. PERT stands for Program Evaluation and Review Technique. CPM stands for Critical Path Method. These are a little bit advanced mathematical techniques which are used in terms of scheduling the projects. Let us look at what is known as job shop technology. So, we have already seen the project part of it. Now, we are going to look at the job shop part of it. It is a process technology which is suitable for a variety of custom designed products in small volumes. Please see, variety is relatively higher, but at the same time the volumes are small volumes. It is appropriate for manufacturers of small batches of many different products, each of which is custom designed. Custom design means one batch of products has nothing to do with another batch of products. They are different from each other, but relatively in smaller volumes, but the variety is going to be higher. Each product requires its own unique set of processing steps or the routing, the path through which the material flows as well as the production processes. Now, what are the characteristics of job shop technology? Now, as I have already mentioned, it produces a variety of jobs, but smaller in numbers. So, for this you need what are known as general purpose equipment with special tools, because you are not producing in a mass manufacturing kind of a system, you are producing in using the job shop technology. Different jobs can be made with the same basic machinery. The material in process follows different processing patterns through the job facilities. So, the material is going to go through different patterns. Job shop also makes to order. Only when you get an order, you are going to make it. A job shop requires highly skilled workers. So, you have different varieties of products, skill levels required are higher, and it also has a flexible layout. Now, what is batch technology? It is a process technology suitable for a variety of products in varying volumes. Variety of products in varying volumes. It is a step up from the job shop technology in terms of product standardization. Relatively, now we are talking about product standardization, products being produced to the same dimensions, to the same sizes. Within the wide range of the products in the batch facility, several are demanded repeatedly in large volumes. So, you can see here very clearly that the volumes are going to change here. The products are demanded in higher volumes. Now, what are the characteristics of batch technology? The items or the articles are manufactured in batches as per the specific order procured. So, you procure the order for different types of items and then you are producing this. Division of labor is possible and flow of materials is intermittent. Probably you would have learnt about division of labor when you studied about the principles of management. So, here specialized labor for different types of activities is possible. So, you have a certain layout of the plant, which is known as a process layout. That means machines of similar types are kept together. Proper maintenance of machinery and equipment is also essential. The process and product planning is done for each batch. That means, since you are having different batches of products, the process planning as well as the product planning is done for each of these batches. Let us look at what is known as assembly line technology. This is a process which is very much suitable for a narrow range of standardized products in high volumes. Now, look at the difference. We are not talking about a variety of products, we are talking about very narrow range of products, but at the same time when you are talking about the volumes, we are talking about higher volumes. Specialized equipment is needed, you have trained people are required, and you have management systems that need to be developed in order to achieve this. There is a continuous and steady flow of material. You are consistently moving the material and then you are producing the products. Say for example, here you can see air conditioners. You produce it in bulk, you do not produce them in smaller volumes. Television sets, cars, watches, you can find multiple examples that could be qualified under what is known as assembly line technology. Now, what are the characteristics of assembly line technology? Machinery is laid as per the sequence of production and material handling will be reduced to minimum level. Flow of the work is balanced, very little time is spent on resetting of the machines. So, work in progress is small compared to the intermittent production. Plant layout and facilities are designed to suit production requirements. Output of one operation becomes the input of the other operation. It offers lowest production cost per unit. Let us look at what is known as continuous flow technology. So, it is a process technology suitable for producing continuous flow of products. You are talking about a continuity in terms of the production. Materials and products are produced in continuous endless flow rather than in batches or discrete items. Here you are not producing item to item, you are producing a continuous flow of whatever you are producing. The product is highly standardized. So, it is quite standardized, manufacturing procedures are standardized, the sequence of the product build up as well as the materials and equipment very clearly are specified. Continuous flow technology efforts high volume around the clock 24/7 operation with a capital intensive specialized automation. Say for example, you look at chemical plants, you look at oil refineries, there is a continuous flow, right. Imagine that there is a company that is producing petroleum or diesel, it is a continuous flow, it is around the clock 24/7 operations. If you look at the process life cycle, right, on the x axis you find the time, on the y axis you are looking at the manufacturing cost per unit. We started with the job shop, then we moved on to batch, then we moved on to assembly line, then we moved on to the continuous flow. You can see very clearly as to how the manufacturing cost per unit from job shop to batch to assembly have decreased, and again with the continuous flow there is an increase, which is very clearly given in the graph. If you look at this particular screen, you will find what is termed as a product process matrix. What do you find on this particular matrix? On the y axis you have the volume, your production or operation volume. On the x axis you are going to have your output variety. Variety means different types of products are produced. On the y axis volume means the number of units, volume high means more number of units, volume less means less number of units. So, in this particular case when you are talking about the continuous production, there is no variety, the same kind of product is produced, but at higher volumes. Mass production, a little bit of variety, but at the same time the output product variety is a little bit, but still the volume is higher. So, when you are talking about batch production, what is happening is the variety is increasing, at the same time the volume is coming down, and when it comes to job shop production, very clearly you are only going to produce if you are receiving an order, and each order is different from the other order. Therefore, the variety is very much, the variety in terms of the products is very high, but the volume is very much low volumes at higher variety. If we are talking about the summary of what we have discussed today, we started with understanding product selection processes and the new product development process. So, what we have discussed is how do you select a product, how does a company actually go with selecting a new product, especially when you would like to enter a market. We said that we are going to look at ideation, that means generation of a lot of ideas, followed by the idea screening, concept development and testing. Then of course, you are also looking at making a business analysis for this particular product. Then you are going with producing what could be termed as a prototype, which is tested, and then if the prototype is working, then you are going to put it in the test markets, and finally, if everything is okay, you are going to make a commercial launch of the product in the markets. That is about the product selection and as well as giving the product or releasing the product into the market. Similarly, we talked about the various types of computer related technologies that are used in production: CAD, computer aided design; CAM, computer aided manufacturing; CAM, computer integrated manufacturing; FMS, flexible manufacturing system. And of course, we also talked about the usage of robots in complex production processes which are repetitive. We also talked about how lean and agile manufacturing are today being used in order to, one is reduce the wastage, at the same time having the capability to adapt to multiple types of changes that are occurring both in the technology as well as in the market conditions. Then of course, we talked about the process selection, where we looked at the different processes right from the job order to the mass production to the continuous production. We looked at the different types of processes that are there. Then we looked at the product life cycle as well as the process life cycle. So, ultimately we are looking at how the product goes through the different phases during its life cycle, and we also looked at what are the different types of process life cycles that are there. And finally, we also looked in terms of the relationship between the product and the process. That means, when you are talking about the interface between the product and the processes, we said that when it comes to let us say job order production, the volume at which you are producing is very high, but then the numbers you are producing is relatively low. Similarly, when you are looking at what could be termed as a mass production, in the mass production, generally the volume at which you are producing products is going to be very high, but then the variety of the products is going to be low. At the other extreme, you are going to have continuous production. So, when you are talking about continuous production, we are looking at a scenario where the product is not measured in terms of distinctive units, but at the same time we can look at a product like petroleum that is produced continuously, round the clock, where there is no change in terms of the product that is being produced, and specialized production processes are being deployed in this, specialized information systems are there, and then we are going with a round the clock continuous production system. Thank you.